So, hi everyone, myself Vikas. I work for GeekyAnts and I'm working from GeekyAnts for now about 8 months now. And I'm going to talk about performance and optimization in Flutter, specific to Flutter. This is not a topic specific to Flutter, but in this talk, we are just sticking to Flutter, that's all. Now, let's jump right into it. Let's cover the topics that we are going to cover in this talk. First of all, we are going to talk about methods and versus widgets. After that, we are going to talk about async await, and after that, concurrency in Dart, and then isolates, and then we will explore some dev tools along with this. So let's talk about methods and widgets. Avoid rebuilding widgets. What does it mean? So I have stated a warning here that don't use long build methods. So why don't we use long build methods? What's the reason? First of all, readability. It's hard to read long long files and stuff like that. Second of all, performance, and we will get into that in few slides. And third one is my personal opinion. It doesn't look good. So what are the solutions? If you don't want to use long build methods, then what are the solutions? Most of the developers would say that break down your code into functions. So, okay, let's do that. Functions or methods. Ignore this cross sign for now. We will talk about that. And functions and methods. So, what we have done here. For example, we have this build method. Here is the build, and we have a very heavy widget. Heavy widget means a long widget, and that heavy widget is combined of three smaller widgets. So it looks good, it works, and you're good. This is a good way to segregate your code until and unless you're not changing the state. So what happens when we change the state in a Flutter app? Let's say that our widget 3 has a small like icon or favorite icon. You can say that. And it changes color on the tab. So what would happen? We will call set state. That's correct. To change the state, we will tell the Flutter that the icon has changed the color. Now you have to change the state of that icon. So what does the set states do? It goes up the widget tree and finds the nearest build method, the first build method that it gets, and for now, which is this one, and it triggers the rebuild. So what happens when it triggers the rebuild? It rebuilds the heavy widget, and heavy widget along with the heavy widget, we got widget 1, widget 2, and widget 3 all gets rebuilds, and that's an issue. Suppose we have a very complex screen. We have post, we have comments, we have app bar, we have bottom navigation bars, and we are only changing a color of small icon in that state. Why are we paying all the performance of building these widgets? So that's not a good option. So what's good? Change them into widgets. That's all. It has all the same structure. We are here all. We are again calling the heavy widget here, but now it's not a method. It's a widget. That means it's its own class. And in that heavy widget, we are calling all those three widgets, and they are on. They are also separate widgets. So what happens when we call the set state now in widget 3? Let's say we call set state for widget 3. Now it will go up the widget tree and finds the nearest build method. And we have that in widget. So it will only rebuild the widget tree. And that's optimized. That's good. That's good. We have done that. But it's now we have created a Flutter app. We have talked about widgets. We have worked with widgets, but an app is only not only consists of widgets and the UI components. We have to fetch data. We have to make some method calls. We have to read files. We have to write files, and thus that brings to our the next topic, async await. So, what is asynchronous programming? Let's talk about asynchronous programming first. And asynchronous programming means any operation in our app that is taking time to finish. For suppose like we are fetching data from the server, writing to our database, reading a file, we are processing images and stuff like that. If it's taking time, then it is asynchronous. So what's the approach? How to make an asynchronous call? How to tell Dart that we are going to take some time to perform this action. You have to work accordingly. So there are multiple approaches. The first one is dot then. Now here we have our crazy complex asynchronous function. What it does, it takes two arguments and after 2 seconds it's kept the sum. So pretty complex, right? So now how to use that? So for to call this function, I have called add, and since it is a future, I can nest dot then to it. And dot then is nothing, just like a callback function. It gets populated, it returns the value when the future or the promise gets resolved. And we can use that here any way we want. So that's good. This is good. It looks good, it feels good, and everything is fine here. So what's the issue? We haven't talked about async await yet. So what's wrong with using dot? The problem starts happening when we try to call multiple asynchronous functions one by one. So now we are chaining, we are calling add, and we have chained dot then to it, and using the value that is returned by first call of to add to call another asynchronous function. That could be any function, but for now, for the time being, we have used add again. So I'm using someone to call add again, and then I have changed another dot then to this, and using that function to and using that function return value to call add again. And for now, we have changed three asynchronous calls in a callback one by one. Now this seems pretty ugly. For me, it seems ugly. It doesn't look good. It's hard to read, and we haven't talked about error handling yet. So let's talk about it. What about error handling in .NET? So there are two ways to do that. We can chain .catch error method to every dot then call we have make, or we can return a future from one of the dot then and then use only one catch error to catch all the errors on the above dot. So this is the pretty basic method of handling errors used when we are using .NET. So, and this is also known as callback help for JavaScript developers. So what we can do now? There comes async await to the rescue. Now, using await, we are telling Dart that you have to stop on this line unless you get the value, and after that you can execute the rest of the below code. So first in the line someone, I have tell add, I have tell Dart to await for the add function to execute, and after the value is returned, then only we can go to sum2, and then we can use the value in sum2 and respectively for sum3. And I have used a try catch to catch all the errors for all the asynchronous functions that I have called. So you can see that how async await changed from this callback held to this heaven. Now, there are some few more benefits to async await regarding the scopes of the values. Here, I have access when I am calling the function for sum3. I have access to the values of sum1, sum2, both. But while I was calling dot then, when I'm calling the add function for sum3, I don't have access to the value of sum1. To make it accessible, I have to define a global variable, and after resolving this, I have to assign that value to this, and that's a lot of work. So that's not good. Use async await. instead of .10. Now, for with this, we have covered async a bit. Now let's talk about concurrency and Dart. What is concurrency? First of all, concurrency means that we have to work on multiple computations simultaneously. Means like I have suppose I have given Dart a task that to read a file, and by using that file, I have to change the UI or something like that. So I don't want Dart to stop for reading that file only and using that while it's reading the file. I don't want Dart to stop all the processes that it was working on previously. So that's bad. That's where concurrency comes in. Concurrency says that we can work on different processes at the same time. So Dart is a single threaded language. We can't do that on a single thread. We have to tell Dart that this is an asynchronous function. You have to run on a different non-Dart VM or the OS on the native level. So for now, we have that's how the thread of Dart works. We have an event queue. Event queue means a queue of the executions, the computations that we have to perform. We are injecting to the Dart thread and stuff like that. And event loop is responsible to execute all those computations. For now, the event loop will trigger the paint frame. And what happens when it comes to tap event? Let's say that tap event is some asynchronous function. Synchronous functions like a function that computes immediately, but for some reasons, like we are reading an extremely large file, and there is a method in Dart that read string as byte sync. So we have tell Dart that this is a synchronous function and we are reading a large file, then it's going to take time. We know that. And same goes for parsing a large JSON. For say that we have an extremely large JSON, let's say of 1 MB. It is a extremely large JSON and we are trying to parse that. That is a synchronous function. Dart doesn't know that it has to wait for it. It has to delegate to the VM, different non-Dart VM, or it has to do it on the native level. So what we can do there, for loading an image, we can use read as file string, and we can use async await to tell Dart that this is going to take time. Please don't block the code and do all the other stuff that you were working on. So what happens when the user taps on the event? This blocks the event loop and thus causing the jitter slash jank in the UI. Means suppose we are fetching a data from the network and we have extremely large JSON in the response and we are showing a loading indicator. So that loading indicator will get paused for a little bit of time, and that is called jam. That is causing because of the parsing of large JSON. So what's the solution here? The solution is simple. Dart is a single threaded language, so delegate that work to other thread. And that brings us to our next topic, isolates. So as I told you that this is a synchronous function, this is going to take time. Dart is a single threaded language. It can't handle all the synchronous functions on same thread. So we try to offload this heavy computation to a different isolate. That's simple. If one worker is not able to perform all the tasks, hire a new employee, hire a new worker. That's easy. So how do we do that? There are two methods to do that. First of all is compute. Compute. First of all, let's talk about a little bit of isolates. Isolates, as the name suggests, they are completely isolated from the Dart main thread. There is no way to share memory between multiple isolates or the main thread or a single isolate. There is a way to send messages, and we are going to talk about that in next slides. And there is a method called compute. Compute doesn't share any kind of messages. It just takes a function to execute. It takes a parameter if we want to provide it a parameter or so, and it returns the value. So what does compute doing here? We said we told Dart that we are using a compute function. We have used await here. We have used async here. We have told Dart that this function is going to take time. So, and we have given it a very complex function, very complex function of providing me a sum with the number of iterations that I provide. That's complex. So what does compute take? Compute takes an function to execute. It takes heavy computations. It takes a parameter if I want to assign it a parameter. It executes the function and it returns the value. Simple. Behind the scenes, compute handles everything of creating a new isolate, destroying the isolate after the computation is over, and stuff like that. What if we want more control over? What if we want to send messages? What if uh, we want to control when an isolate gets destroyed? So for that we have isolate.spawn. So what are we doing here? We have a function called isolate spawn. It's gonna return us JSON data after it's getting passed and stuff like that. And again, we have told Dart that this function is gonna take time, and we have used async and await here. So Dart knows that it doesn't have to block all the execution of other repainting events or any events. So what does isolate.spawn do? Isolate spawn, this is a port. First of all, we define a port, receive port, and using this port, we are gonna send messages and communicate between the isolate. So let's call that method await. We are going to await for the method isolate.spawn, and isolate.spawn as compute. It also takes a function to execute, and it takes a port. The port dot send port means send port is an extension of receive port, an argument, and using that port we can send messages from one isolate to the main thread by writing port dot send and the message. And here we can listen on that port dot listen, and we can listen to those messages and perform certain actions using that. So read and pass JSON is doing what it's doing. It's reading a file, and it's reading a file which is going to return a very large uh, data, and after that we are decoding that data and returning that data to the isolate spawn. So isolate.exit, what does it doing? It destroying the isolate and returning the JSON data at the same time. So here we have complete control of when we are going to create an isolate, when we are going to destroy an isolate. So we have talked about async await, methods, widgets, methods versus widgets. We have talked about concurrency. We have talked about isolates. So the thing comes that when to use them. How do we know that this portion of the app is taking is taking too much time? This portion is creating the jank. This is the issue where we have to look that this API is sending a very large JSON as a response. So for that, let's get to our next topic, DevTools. Flutter has an extremely good collection of DevTools. We can say that it is one of the best, actually. We can inspect the UI layout. We can we can see the change in frame rates. We can do the profiling. We can see the network calls made by the API. We can see the how much memory it's taking. We can analyze the code. We can check what size the app, and lot and many more. So we will talk about some of that stuff. So first one is Flutter Inspector. I think every one of the Flutter developer has worked with Flutter Inspector. So how does it work? If no one has worked with before, I don't know what they are doing. We have to enable this. Select widget mode. After enabling this, we get a screen like this that it shows an overlay that we can select any kind of any widgets in the UI. And while after I tap, on the UI, it shows me the layout, that how it is rendered, and the best part of it all, it takes me to the code where that UI component has been written. So while working with a large app, it is one of the most used tool to go to the specific component that you have to work on, and that's the power of Flutter Inspector. And after that, we have performance overlay. Here we can figure out what part of the UI is causing the jank, the jitter, and stuff like that. To do that, you can always enable performance overlay, and with this, you will get an overlay in your app itself, that how it is going to perform. And when you get this overlay, you can scroll through your app, you can perform actions, and that will give you an graph of the frame rates that you are getting on that specific portion. And by that, you will be able to determine that which part of the UI is causing the problem, or the jitter, or the jam. The next and my favorite is the network tab. Here you can see what API calls your app have made. You can see the response, you can see the data, you can see the headers that you have thrown, you can see whether check what is the size of the JSON that you got, and many more. So that's all. Thank you, guys.